Hello, everyone. My name is Dr. Henry Debem. I will be taking you through Introduction to SPSS, just for you to have an idea, the basic procedures and the operations of the SPSS for your research studies. So I will have to share my screen and run you through the slides and the outline of what I'll be taking you through. Okay. So okay. Okay. So let me just run through this. So just to take you through the outline. So these are the learning outcomes and objectives of this session. So at the end of this session, you should be able to understand the basis for choosing appropriate statistical test or plan for your research. Then you should be able to demonstrate the basic skills in the use of SPSS and perform basic relevant analysis, using the SPSS. Okay, so these are the task outline. I would want to run you through preparation of data sets and looking at how you import your data set from a spreadsheet. I'll also show you how to do some data entries using the SPSS, and you'll be able to learn how to label data codes when you have some data coming in strings or in numbers that have no codes, so for you to be able to understand those codes or those numbers. So for you to just assign a kind of a text or string to it so you can recognize it, that is labeling the data codes. Then you also learn how to recode numerical into categorical variables when you have several interval data or continuous data that just run through in numbers, and you want to convert them into categories or groups. So you will see how to do that. Then you'll be able to do some few data computations, and the last session here should be being able to run some basic descriptive statistics and inferential statistics. And for the inferential statistics, maybe I've looked at those tests that I think that are very relevant for you, that'll be relevant in your research or your studies. So shall be looking at t-tests, one way ANOVA, contingency table and chi-square, linear regression model, and binary regression and binary logistic regression model. Okay, let's get started. However, before we run into the main task, I think it's very appropriate for you to understand how to make best decisions on your choice of statistical tests, data analysis plan. This is a common problem among all students, being able to make the appropriate, use appropriate tests for their research. Oftentimes, you have to start thinking about your statistical plan starting from the beginning of your research, as you're still trying to understand the aim, the objectives, the research questions, the purpose of your research. You should start thinking about your statistical plan. But most students do not do this. They just jump into research or into studies, and by the time they get to data analysis, they start struggling to know exactly which statistical test to be appropriate for their studies. And oftentimes, they run into problem, at that point. So let's just, let me take you through this. Now, what you would want to know is that just to understand that every research you're going to do, every studies you're going to carry out at this time, especially at the master's level, even at the PhD level, would fall into three main categories. And these are the categories. First, you might be looking at just summary of univariate data when you are looking at descriptive statistics, just to summarize data sets, to have an overview, a general understanding of what the data set is all about. So there you're just looking at one data set and certain characteristics that you could use to define or summarize that data. And oftentimes, if you are dealing with continuous data, you start looking at using your mean, standard deviations, variance, and so on. But if you're looking at categorical data, then you should be looking at frequency. And I'm sure that by now you should be able to know the difference between continuous data and categorical data. It's a basic requirement here, because I wouldn't have much time to trade it, but that's what I guess you should know. And maybe my colleague must have, mentioned that in his lecture as well. So this is the first, and the simplest of the studies one will want to carry out. And the kind of things you might find things like prevalence here, and prevalence, having to say what proportion of people within a population that has certain criteria or certain characteristics, or maybe like have certain diseases, if you're looking at prevalence, or certain characteristics like maybe age, what population, sorry, not age, marital status, for example, sex or gender, what proportion of this group, against that group, or which is the of this level, maybe education has the highest proportion or highest characteristics of a certain variable in terms of different levels of the variables. So that's, you just want to look at it and have an idea. So when you are discussing overall general characteristics of your population or your sample, this what you would use. So that's where you start looking at the mean for continuous variable, mean, median, and so on and so forth. And the other, for the categorical, you look at the percentages or proportions or frequency tables and so on. Now that is one set. The second set there, category here, is the exploring relationships between variables. This is the commonest of the research my students would carry out. You just want to see how certain variables relate with each other, how certain independent variables or one independent variable is associated or related to an outcome variable, which is dependent variable. So it's very, very common. So I'm sure that most of your researches or studies, for those who are interested in running quantitative study, will fall into this category. Then the last of the categories is the testing of significance of differences. When you want to see if there is a significant difference between certain groups, maybe two groups or more, just looking at one measure, one variable or value that you want to run through to see how these groups, different groups, how they differ. Are they about the same thing or there are differences? Looking at one. So I will come to that situation where you'll be looking at either one variable or two variables and so on and so forth. So that is that. I have explained the first one. Now let's go to the second one, which is exploring the relationship between variables. Now, the question you ask is that, okay, you want to look at two variables, you want to look at relationship between variables, either one or two or three. But the first question you ask is, the variables, are they categorical variables or continuous variables? If they are categorical variables, which is represented here as the frequency, then you want to consider the number of variables you're looking at. If you're looking at just one categorical variable, probably you want to see how the distribution of that variable fits in into the general population or theoretical population. Usually it's assumed to say compare how it's normally distributed, the normal distribution of that variable you're looking at, that's distribution of your observations of the data. So if that's what you want to do, then you consider chi-square goodness of fit test. Chi-square goodness of fit test, like you said, like you mentioned, you just want to see how it fits into. Usually, I think the theoretical assumption here is seeing how it fits into the same data in a general population, assuming a normal, distribution. So see how it fits in, and if it doesn't fit in, basically that's just what you want to see there. While the second has to do with two. When you're looking at two variables now, so you want to look at testing associations between two variables. right? So for example, you want to say if age as a base, I will still may come to where just to give you a general idea, but it will come to maybe say if levels of education, how levels of education, of how marital status, it's associated with levels of education, have different marital status, like single, widowed, never married, and married, and so on. So you want to see how it's related to their educational status. Maybe trying to see if there's any kind of association. Maybe looking at the having no education at all, primary education, secondary or tertiary. So that's that. So you're looking at two, and you want to see how they are linked. So when you have such, now one usually something like maybe the education will usually be the outcome variable, why the other will be independent variable. Maybe something like marital status. If you want to look at how the two are associated, you may also want to look at, for example, the income level of women, how is associated with the vaccination of their children, whether they are vaccinated of, having a particular vaccination, yes or no, and looking at income levels of women and see if they are associated, something like that. So you look at chi-square. So in this case, you have two categories. Okay, now let's move to the measurement. So the measurement is when you have continuous variables, two or more continuous variables, because the first question should be, are you looking at just one or two or more, right? So if you are looking at two variables to see how they are related, then you want to know if the continuous variables, if the data is normally distributed. So the normal distribution is an assumption of parametric analysis or parametric tests. So when you hear some statistical tests, some are considered as non-parametric, while some are parametric. So the distribution pattern of that data is what is first considered. So if you miss the assumption of distribution, then you consider the parametric test, which is considered here as interval, and you do the independent sample t-test, independent sample t-test. But if it's non-parametric, right, probably does not follow. Of course, there will be tests. Maybe if I have some time, I might just link on that, how to check. But the one that is the easiest is to see, check the ball. If you run the test in a histogram, and create a histogram from the data set and see if it has a, bell shape. Yeah, if it has a bell shape, but if it's not, of course, how bell shape looks like, starts from the shallow end and gets up, then comes down towards the end. So the two ends are kind of shallow, while the center, just the bell shape. So if you run a histogram on that data set, you will see it. But you also have another test, how you can run that to just be sure if it is or not. Oftentimes, some authors could just look at if that test is less than, if I have less than 30 observations, you just go straight to assume non-parametric or non-normal distribution. But if it's more than that, why some authors could look at anything less than 100. But usually, I think the one that is common, if it's less than 30 in number, have a sample size of less than 30 or about 30, it also non-parametric. Non-parametric is a kind of a more robust. It has more robust considerations in a test to consider the lack of normality, in the distribution of the data sets. So that is what it is. Now you move to the next one. So like I said, where am I? Okay. Now, if you're considering if you have like many independent variables that are, this is just beyond two independent, two variables now. So you have more, like 3, 4, 5 more variables, then one. So you have many independent variables as against one dependent variable. That's one outcome variable. Then you consider multiple regression. So usually multiple regression deals with several continuous variables against one exposure one outcome or dependent variable. That's when used. So let me take you back a bit on this, on the categorical variable. after the chi-square. So there are situations where it's not represented here, but there are situations where you might have more than 2 variables against one categorical variable, usually binary outcome. That's just 2 levels of outcomes, yes or no, boy, girl, something like that. So if you have such dependent variable, and you want to see how several categorical or continuous variables could predict or are associated or related with that dependent variable. So you consider binary logistics regression. It's not here, or multiple binary logistics regression. The binary there means that the outcome variable will have only 2 levels of consideration, yes or no. That's the binary. Why you could have many other independent variables, many. You can have mixture of continuous and logistics. Yes, if you have such, you use binary logistics regression, right? Now we move to, okay, so I'm done with this. Okay, yeah. So we now move to the last category, which is testing significance, and differences across different groups or different level of different categories. So you want to see the difference. Just for example, you want to see if you have several classes, school community, you just look at several classes. You want to see if their heights, they have differences in heights. You have class A, class B, class C. You can have 2 classes. There are so many ways you can do that comparison. But if you're looking at one continuous variable across different groups to see how they compare, this is where you focus. So first, the first question you ask here is, if you're looking at just one sample, one group, and you want to compare it to a specified value, maybe that you got from a publication or theoretical value, you just want to compare, you've read it somewhere or from the report, and you want to compare the mean estimate of that group with this theoretical value. You just used the one sample t-test. While if you have 2 groups, okay, you want to compare how this measure compares across these 2 groups, you consider if those groups are independent samples. Independent means you have 2 groups that are not related in any way. They are mutually exclusive. What happens in one group does not affect the other. So if you're looking at, for example, in a class, you're looking at gender, the female and male in a class, what happens in the female group does not affect the male group. So they're just mutually exclusive. And you now want to see if they have the same height or how they compare these 2 groups, how they compare in their height measures. So if you have that kind of, so the first is to ask the height, that is the outcome variable now you are measuring, is it continuous? Does it meet the assumption of normal distribution? So that is represented here as interval or ratio. If yes, then you run independent sample t-test. But if it doesn't meet that assumption, maybe in ordinary ordinal scale, then you consider Mann-Whitney U-test. That is the non-parametric form of independent samples t-test. Then you also go back and check if these 2 samples are related. Related means you just have one sample. Okay, you can have 2 measures from one group. So you want to look like, this is where the pre-intervention and post-intervention study design comes in. You want to have a group. You want to see what happens before an intervention and what still happens on the same measure after intervention. So you're looking at pre and post intervention, but we are just working on the same group. If anything happens on that group, it affects the possible outcome as in post measure. So this, if you have such kind of sample, then you ask the same question. The data you want to measure, is it interval or ratio that's normally distributed or not? If it's normally distributed, then you conduct the paired sample t-test. Paired samples t-test. If it's not, the non-parametric version of this is the Wilcoxon matched pairs test. That's what you consider. The last here looks at multiple, because this other one is just 2. You're looking at 2 variables here, right? While this last one considers more than 2 variables. So you can have one outcome variable and 2 or 3 other independent variables. So by independent variables, we are looking at, you could have one group, but you could have a group of people, but what you're looking at different variables, or different samples. So if you say group of people, like have a people in the class, that's one population, but you can have different groups within them, which you could also refer as variables. For example, if you talk about gender or sex, for example, so you're looking at female and male. So in this case, you're not only considering sex, you're also considering educational level. So you want to also see how the educational level and the gender of that group compares, how they differ in how the heights of these different groups, differ across these different variables. So in stress statistical understanding, one could just look at it as, you want to see if these different variables have any significant effect on height. That is, if you are using height as an outcome variable, right? You just want to say, but let me use better one. You might not look at height. You could just look at score, maybe an exam score, physics score. So you want to see if the gender and different educational background or ethnicity, or ethnicity of that class had any significant effect on their scores. So these are how certain kind of studies we'd want to consider, within this context. So when you look at that, so the question, yes, multiple variables. So you now say, are they independent samples? Like I've explained on, about having independent samples. So they are all mutually exclusive. If that is yes, you consider, is it one independent variable? One independent variable, this means one independent variable with more than two levels. One independent variable with more than two levels. So you can have something like marital status. You want to see how their marital status could affect their scores, their math scores, right? So you could have like 4 different levels. So if you have such, then you consider it one way ANOVA. One way ANOVA. One way here means one variable. That's how to recognize that. One way ANOVA, one variable, but could have more than 2 different categories. Why the multiple independent variable here? So you have like more than one variable, like I mentioned, age and marital status, example, and see, sorry, not age, I keep on using age, gender, for example, and marital status, and see how it could affect the math score of the students. So that's when you consider multifactorial ANOVA. Why the one on the extreme is, if you're looking at related, like I mentioned earlier, and have related sample, just maybe considering one sample of people, or group, but you are taking repeated, just like I mentioned in the pre and post intervention measures. So this time around, we are having interval measures, as in occasionally, once in a while, you have some kind of spread out measures within that group. So as you are providing intervention, you are taking measures occasionally or within fixed, routine, maybe regularly, like every month, you take the measurement every month. So you want to see the pattern and how the measurement, how the values changes over time with, same intervention. So you might decide to run a project of 1 year, research of 1 year, and you're providing intervention to this group of people, and you're taking monthly measures or quarterly measures. So for quarterly measures, that means you're looking at taking repeatedly 4 different measures within 1 year. So when you are doing such, then you consider repeated measures of ANOVA. So sorry, I hope you make good sense out of this. So that is all about making the right choice of your data analysis plan, designed on time as you are thinking about your studies, having aim, defining the purpose, defining the research questions. You have to make this decision before you go ahead. And these are the things that are so important, even as you're writing your protocol for your studies. So now we can go to, let me take you to, sorry, I have to stop sharing now. Okay. So let me take you to main statistics. Okay, so here, when you open, if you open your SPSS, okay, So if you open your SPSS, you will find two windows. This is the data window, the first, that's the data window, and the output window. This is the output window. So all the analysis you conduct, generate or create, you'll find the output tables, the results here. While the other is where you run your data, do your manipulations and run your analysis, and you see it in the output window. So this has to do with data section. And under the data section, you will find two key windows as well, or views. This is data view. This is where you are. And this next one is called the variable view. The variable data view, this is where you make your data entry. If you do any import from spreadsheet, this is where you find the data. Why the variable view is, this is where you create the variables that you want to make entries on. And even if you make any imports, this is where you find the variable characteristics, the descriptions, and this, you make some manipulations, some adjustments here, depending on what you want. So this is where you work on the data characteristics itself. Why data view? This is where you find the data and you do the entries. Let me start with the work for the data, for the variable view. So what you do here, the variable view, is, for example, you want to enter your data, you want to create your data entry instrument or tool, or in the SPSS. So this is where you start. So for example, we start with case ID, and remember, this is the variable name. That's what the SPSS could recognize quickly. So you give it name, and here it doesn't accept spaces. Even though in this version, this is version 26, SPSS 26. It has some amazing features already that could help you with some corrections. For example, if you don't have space, it could help you. It will let you know, but fix it for you, right? So if I say variable space ID, you see, the variable name contains an illegal character, which is the space. So you don't have to do that. So you type again, case ID. This is accepted. Okay, so again, something like age. You just give the names now. Marital status. Like I said, no space. So it will always, okay, it doesn't fix, maybe not this. So you fix it yourself. Status. Okay, what else? Education level. So just leave it at this, and let me just put score, whatever score. Okay. So this is where you create. Yeah. So if you go to data view, you will see all those variable names here, telling you that it's ready for you to start making your entries, right? So on your case, you can say 001, 002. It doesn't. You just have to. No, yeah, except if you saw something like 001 like that. So it will just give you 002, 003, 1003. Now age, you want to look at age. Okay, 23, 45, 16. Now marital status. There's something you need to understand here. The first condition, favorable condition, it's a good one for SPSS, is to try to represent all your data in numbers. All your data should be in numbers. Yes, there's provision for strings, text, other kind of data, but it runs better with numbers, SPSS. So rather than having strings, I advise you put it in numbers, and I'll show you where to put the code so that you can know how you code them. You know what each of the numbers or codes represents, for readability. So if you have something like marital status, let's assume you have the codes already, 1, 2, 3, like that. Education, you have another code, 1, 2, 2. Then scores for whatever, you have 30, 45, 45, 32, and 19. Okay. Okay. So this is what you have. Now, first thing you discover that you have lots of these decimal points that are making it look a bit clumsy, and you want to just make it look a bit simple. You know, you don't want to have a lot of numbers that are not relevant. So this is, you go to the variable view, like I told you, this is where you do a lot of manipulations you want to do. So you can find decimals here. You just need to make it 0, you know, change it to 0, 0. So I'll just get back to 0. Go back to data view. You see all those decimal places are lost. Okay. Now, like I told you, if you let me show you something on education. For marital status, for example, you can see this is where you find the data types. You know, so the data types here are numeric. That's the preference of SPSS. But you have an option of changing it to any of these, string or anything, right? Date and so on. However, okay, I'll come to that. Then width, this is the number of digits that could be allowed for you to enter for each of these variables. So you have maximum number of 8, so you can reduce them to 2, 3, 4, or depending. You have decimal point. Label, this is where you try to put little definition or description of the variable name so that you don't forget. You know, if you are doing very massive study, there might be situations where you just be using numbers because there are whole lots of similar variables with just slight differences. So you could just use numbers and be going on, or some very codes that are difficult to understand. So this is where you label them for you to understand. So here you can say study unique ID. So here accept spaces. You know, you don't need to, you know, get worried about the spaces. So that's fine. Age, you know, current age of participants, you know, and so on. So marital, you continue like that. So you can do your definitions here. Values. So this is where you do your recoding. I know it's one of the things I want to take you through. So, but maybe let me just do it now since it's appropriate now. So like you have recording, you have marital status. So when you go to data view, you discover marital status just 1, 2, 3. But already you know the code. You know what 1 means. You know what 2 means. You know what 3 means. But it doesn't show here. So this is where you can indicate all that. So here you can say, okay, 1 means single. You say add. 2 means married. Add. And 3. I don't think there's 3, but just in case. So you can have 3. 3 says separated. You add. Okay. So once you do this, you go back to data view. This is marital status. If you want to know what this means, you go to, okay. So if you want to, so you go to value labels here. This is the icon for value labels. So you go there. Once you click, it will come show you the codes. You know, this is just straightforward. Now, anyone that doesn't show code like educational level, it means that you haven't coded the data. You haven't coded the data, right? So you can go back, follow the same education status and do the same, code them, you know, depending on whatever you want to do. So it's good because SPSS recognizes that numbers and it can work better, a lot better. Maybe in the course of the analysis, you will see maybe one example that could come clearly to show you why SPSS would prefer just having them in numbers and coding. Now, that is not to say that you don't have provision for, you know, text or strings. You can, for example, educational here, you can change it to strings. Once you change it to strings, if you go back to data view, so what it means, okay, sorry, let me go back and show you. So what it means that if it's in numeric, and you put strings like no education, if you do that, it will still go back to 1. It won't accept that. So because it's numeric type already. So for you to accept any string, you have to go back here and change it from here by just clicking here and say string values. Okay, you go back. So this is, now you can accept no education. Now, so you can accept this, no edu. So it, like we said, the string, it can't take more than, you just have no educa. You can't take more than that because the string width here is 8. So except you increase it more than, you know, to something, you so that you can finish up. So you can accept more than that, you can. So that is that. But if it's less than that, it shouldn't. That's how it works. So, but like I told you, I prefer to have them in numbers. Okay. And you have your coding. So that's all for now for data entry. So you have your columns, you don't have much here. You have a line, measure. So measure here, yes, it's fine. You want to also, define the measure type. Case ID, you can call it ordinal since it's not just an ID representing each of the cases or records. Here, age could be scale. What do you have here? Marital status, this could be nominal. Educational level could be ordinal. Scores here could be scale, So why you do this is it's easier. You are just making it easier for SPSS to run your analysis for you with all this understanding. So I think other things are, okay, another one that might matter, missing. There are situations, okay, I will show the imports and maybe I'll take one example from there to show you, but there are situations where you can import data. I discover that SPSS is, you have some data that spaces that are not recognized are recognized as values, but nothing in there, but they're recognized as values. Or you could have some numbers like unknown is coded with a number and SPSS is reading it as part of the value. Some numbers that are you got from the download from your database from source, it's coded like 99, but here SPSS would say it's the 99 there could mean missing. That's how it's coded. So you need to let SPSS know that, for example, if I'm looking at age, so you're telling it that you can go to discrete. This means no missing values. So it's assuming, if it's assuming that there is no missing values. So even if you have spaces there, any number there is considered as a value, nothing missing. But here you can tell SPSS that no, discrete missing values could be just a space. That means any empty space considered as missing. Then you might want to code some other missing, or you got it from the imported extracted data from any source. You can say, okay, any number as 99 or value as 99 or whatever number, or 7 or 8, consider it as missing. You have an idea what that means. So once you do that, you say, okay, sorry, incorrect value. Okay, sorry. Okay, yes, there is none. There's no, okay, let me go back. There's no value there for 99. So let me go back. What's age? Okay. So let's assume you have age. Okay, another case, 004, right? Yeah, and this is missing. You have 2, married, and whatever you've. Okay, yeah. So here is still, we did, so that's why it's already string now. So it's considered a string until we change that. Nevertheless, let me just leave it as string. Say primary. Okay, now, so have another one that says 6, then let me say 99 or 77, whatever. Okay, let's leave others. Just age. So when you go back here, if you run any analysis the way it is, SPSS will consider 77 as age and not missing. And if you run something like frequency, it will consider a space as a value. That's how it runs. So for you to maybe, okay, I will get there. I just don't want to jump so that you don't get confused. But just to tell you what to do. So once you get here, all you just need to do is when you get to age, go to missing. So first one, sorry, yeah, space, consider space as missing, and 77 as, looks like I'm missing something. Am I not in age? Hold on, sorry. Okay. Sorry, okay, I think 77 now. Yeah. Okay, so 77 is considered. So I think what it was querying is already, because you did entry, I was trying to explain when you import data that comes with space, any data set that comes with space. So you need to show space as missing and whatever number. But because you enter directly into SPSS, so it's considered any space with this dot. Dot means it's considered it as missing. Any dot is missing for numerical data, right? So that's what you should. So now 77 means missing. So if you're doing any competition, any kind of a competition, I mean computation, right? So you wouldn't consider 77. It's considered as missing. Now let me take you to the next one: how to import data. Maybe you've downloaded data from the source and put them in, if it's not in the SPSS, maybe you have them in spreadsheet like Excel. So you go to import, from file, import Excel. So I have dummy data Excel already, just to quicken the process. So I can double click on that. So but what it should have done is to locate where the Excel file is, just locate where it is. That's what it should do, and double click on it. Then it brings it out in this form. Now you need to be very careful and be sure that the data you have in Excel know these sheets, because I have sheet 1, sheet 2, sheet spreadsheet 3, and so on. So the one I have is in, I want to work with, is in spread 2, sheet 2. So be careful, because if you pick the wrong sheet and probably you have a lot of data, you might be working with the wrong data without you knowing that. So be very careful with that. Then you can leave everything in the dialog, leave everything the way that it is, default, that's fine. So you're just trying to say reading variable names from the first row of data. So if you have your variable name in the first row of your Excel, you're saying yes, read from there, and consider percentage of values that determine data type up to 99%. You know, that's what it will read as a data type. Then consider hidden rows and columns. If you have hidden rows in the Excel, you're saying consider them hidden, don't bring them into SPSS. But if you open them up, or even if you hide them, you can, you know, uncheck to say to consider all those hidden rows as part of the data in the SPSS. Just remove the leading spaces. If you have some spaces on the string variables, either in the beginning or the end, you're saying that you should remove them. But if you're very sure you are getting sourcing from the credible data source, they don't need to remove them, you know, because most of those things are worked out there, and they're very clean. But if you are, you know, generate it yourself and you think there might be some possibility of error in doing those entries, then you might want to check them. But as it is, I'm fine with it. So is it okay? Yeah. So you have them imported in your data and your SPSS, and this is the data view like I told you. So you have all my data already imported in the SPSS. Then I can go to the variable view to see all of them, all described or defined based on the characteristics that the SPSS, you know, reads from the Excel sheet you imported. But again, you might find a situation where you might want to make some changes. They're not exactly how you want them. You know, you might want to. There are some changes I made here just for teaching sake. Like initially, I have ethnicity coming in strings, even though they are in numbers. So there are possible situations that you can have some numbers in, you can have some variables in data in numbers, but SPSS considers them as strings, not numbers. Yes, it's possible. So it's your work duty now, either to go back to, especially when you have mixture of numbers and texts, you know. So if it sees a reasonable number of texts, it considers all the column as strings. But if you have all numbers, it automatically considers them as numbers. So if you have that situation where you could have, like I told you, SPSS runs better with numerical data. So you can have your coding, even if you have something like, for example, social status here, you have poorer, poorest, and middle, and so on and so forth. So SPSS could run this as strings, but if you're not doing just descriptive statistics, you want to go further into inferential statistics, I would advise you run them. So here I converted them in codes from the Excel, but you can also do it, you know, here, convert them to codes, but it's quite just some reasonable process for you to do that. So this is how to do your importation. Okay, and I've also showed you how to do your recoding. Like you have numbers, for example. Okay, this is a good example. Though this is different, they're all two different variables, but I'm just kind of coding this. But what will happen is that if you run any analysis with this, it will come as numbers because you've not coded them in the SPSS. Oh, sorry. So you've not coded them in the SPSS. So what would you do? So let me show you an example, just run with this. So if you do some analyze, go to descriptive statistics and frequency, and you look at social status, the one I've recorded in Excel to be in numbers, you say, okay, so this is what you find in the variable view. You will see them 1, 2, 3, 4. You see here, so you don't understand where it is, but SPSS loves it this way. But you also want to see how it runs. Again, if you run the same thing using the other social status that is on string or text type, you see it will come as text type, so you will know exactly which one is which, right? But I advise that you keep them in numerical and code them inside SPSS and use social status too. So how do you do that? So you go back to your data view, go back to variable view rather, then look such, okay, yeah, and see it here. So you have it here, social status 2. So how do you record them? You can record it by, you go to values, like I told you. So you can say 1 represents poorer or something, just for illustration, sorry. Change. Okay, so 2, sorry, no. Okay, I think for, okay, let me see if I could, let me just have a good idea of what is. So I'll just use exactly, okay, let me even use something else. Okay, 2 is poor. Middle, 4, rich. Social status, right? Okay, so, okay, let me change this to poorest. Change. So you say, okay, so what, if you do it, you've told SPSS that these are the codes, libraries for those codes. So if you go back, run descriptives again, frequency, and repeat this again, say, okay. So you say social status 2, poorest, poor, middle, rich. So you're clear. You can read it. You don't just read the numbers. So like I said, that's fine. Now that's how to import and do some manipulations. I don't know if, I'm not sure if I have any other thing I will want to show you. Okay, fine. So let's go to some data transformation. For example, you have age. You have age, data view. This is current age. This is age, right? Okay, so, and you have them here. So you just want to put them in 3 categories or 4, categories, just age groups, right? So how do you convert that? You would, first, I wanted to, okay, run a kind of descriptive of age, just descriptives. You see where I've gone to from analyze, then descriptives. So you put age there and never mind, let me see. Okay, what you want to see, minimum, that's my interest here, minimum and maximum. I don't care about others, just for this. Okay, so you say, okay, now I just want to know the minimum age here is 15, the maximum age is 49, just to help me to know how to break them into groups. So that is fine. So I can go to transform. You always find this menu, whether under output view or data view. So you go to transform, go to recode in different variables. Recoding in the same variable means when you complete the recoding, it will record in the same age, current age variable. So you wouldn't have access to the original column, original data set variable in case you want to make some references. Okay, so it's not it's not advisable to record in the same variable. So record in different variable, then you pick age. This is variable one record. So what's the new name? You may call it, you can call it age 2, age 2. Okay, sorry, age group. Okay, so the label like you have on the variable view, you can say age group of the participants. Okay, age group of the participants. Okay, change the. Okay, so you now go to old and new variables. This is where you do most of the recording. There are so many ways of doing that, but the ones that would be applicable here is using the range type. So you want to look at certain range. So you can say age 15 through 20, right? The value 1. That's how. Then you look at 21, for example, through 30. So you have it, that's under group 2. 31 through 40. Make it group 4. Oh, sorry. 31. No, sorry. Excuse me, sorry. So yeah, so you can run that. I make it to change. Okay, 3. Okay, so you know for 40 and above, you can take range value to highest. You can say range value, so 41 and above, and you can represent them as 4. So you have continue, then you can say okay. So once you do this, go back to data view and see the kind of changes you expect. So you can scroll to the end. You can see the age group all coded, you know, different categories. So you can also go to variable view and so variable view, you can look at this. So age group, right? So you can find it here. So this is age group. You have, so you can make any other manipulations or changes or adjustments you want to do here at the characteristics to have what you want. So this is excellent by me, right? So that's how to do that. Now you can run the analysis, descriptives, frequencies, descriptive statistics, then frequency. So you can down to age group. Okay, leave that as this. So, okay. So here you can find, you see, all the coded in different groups. So you can find 1, 2, 3, but like I told you, you always need to put the codes like I've taught you before. So you can, this is how to do this code as well, because it's very important that you understand this. You can do such codes as in recording the numerical variable there. So you go to values. So you can say 1, if you remember, your 1 is 15 to 20, add. 2 is 21 to 30, add. 3, you have 31 to 40, add. And 4, you have, you can say 41, or okay, 41 plus. You can leave it at this. Okay, and it said okay. So once it's already coded, so you can go back, run the analysis again, just frequency, okay, as it is. Okay, you can see. So this is what it shows you. You know, it's so you have all the 8 categories clearly, so you'll be able to run your interpretations well. So that is fine. Then what else again? Okay, lastly on data processing, preps, you can computation. Yeah, I want to show you that. So let's look at data sets again. So when you go to data view, you discover there's a place I have scores physics, you have health scores, physics scores, math scores. So these students, they have taken these exams and these are their scores, and you want to know what is the total scores for each of the students. You know, you just want to add it up and create another variable. So what you do, you go back to transformation, go to compute variables, go to compute variable, score total, and yeah, score total. You need to, okay. Then just double click. It gets into the numeric expression. You show your expression adding. You can also physics plus and math scores. That's all. Okay, and you say, okay. Once you do this, so you go back to and see what you've done. So you can scroll to the extreme and see your total scores, you know, all added. And you can also check your variable view and see it here in case if you also want to do some other things like change decimal points to category, I mean, converting to groups, you know, like I mentioned before. So they're all in scale. Okay, it's already in scale, so that's recognized. So just like I did in age, you can might decide to put different groups, maybe high scores, low scores, poor scores in different categories using the same method I showed you in age with age variable. So this is how to do computation. So you can do a whole lot of other computations. You can do divisions, you can do multiplications, you can do average, you know, all lots that, just following that. So this is fine for data transformation, data processes, and so on. So let's quickly run through the analysis. And the first here